All right, Algebra 1, we are going to wrap up Chapter 3 by talking about unions and intersections. We have brought this idea of unions together already, and it's brought to you by a guy named George Cantor, from a long time ago. You can see he was born in 1845, and he was one that is attributed to many of these ideas we're going to talk about today. And he said, a set is many that allow themselves to be thought of as one. So what a great unity idea, whether that's your family, your class, or whatever it is. Right? So if you allow yourself to be part of something bigger than you, so that's what George said is a union. All right, so Venn diagram, that's one thing. We can make this pretty visual. Right, so if it is a union, it's everything in A and everything in B. It's not just the area in between. Okay, and then what happens is we end up saying that for an intersection, then those are the things that they share. Okay, so your idea is that we have these two major roads that cross over here, and the intersection, right, that's the area that they share. Okay, so that means we have to have just those two things. Okay, so union is all of those things, and notice we use the U shape for it. The intersection, this is what we were talking about before. Okay, and we use that N shape for it. This is what we tie to and. Okay, so we use that idea of an N and an and. All right, and one thing that hasn't happened yet, but it will happen as we talk about sets today, is if all of A and all of B are completely different. So let's say these are evens and these are odds. Right, then we could say, you know what, A and B, they don't share anything. Okay, so we could have, and that's going to happen when we're trying to get a union disjoint set. All right, so in a union of P and Q, X is whole numbers less than 5. Okay, remember whole numbers. So P is made up of 0, 1, 2, 3, 4, less than 5. Okay. Doesn't say less than or equal to. Q, even natural numbers. So my first natural number would be 1, but here it's going to be 2 because you're talking about evens, 4, and they have to be less than 5. All right, so if we want the union, that means we want all these things that are together. So it's actually just the set of P. So 0, 1, skip my 1 already. 1, 2, 3, 4. Okay, so that would be the union of P and Q. Okay, so I'm going to put some brackets around it. Say that is the union of both. All right, remember intersection, that's what we're going to deal with more because it's a little more thought-provoking. That's the area of the road that's shared. So that means we're talking about things that are shared. So X is natural numbers less than 19. So what's that set look like? 1, 2, 3, you get the idea. Less than 19, so we'll stop there. What's Z? Z is made up of multiple of 6. 6, 12, 18, 24. All right, since I'm looking for an intersection, I don't need all of them. I'm just looking for things that I have in both. So 6, is 6 in the other list? Yes. 12, is 12 in the other list? Yes. 18, yes, that's where my other list stops. Okay, so what's the intersection? What's shared in both of these? So this is made up of 6, 12, and 18 for my final answer. Right, because that's where these two roads crossed over. Those are the items that we have in common. All right, so we have Z already listed up here. So I just need to write out Y real quick so we can see what it is. Y is an odd integer. Okay. It's 1. Well, I don't see anything going on with those negatives. 2, 3, 4. Oh, whoa, what am I doing? Can't put evens in there. 3, 5, 7, 9, 11, 13. Wait a minute. What's going on here? Right, so I need the intersection. So what's shared between odd numbers and multiples of 6? All right, so look at my multiples of 6. I get 6, I get 12, even. Oh my goodness, what's going to happen? This is a disjoint set. All right, now I was just kind of like letting us think through that whole process, but it also becomes very, very clear once we start seeing the sets written out. So once I started writing 1, 3, 5, 7, 9, you're like, wait, we skipped 6, and then we skipped 12, and we would skip 18 if we got to it. So that's where I keep saying seeing is believing. Right? So once we see these things, we can say, oh, that's a lot easier to answer, and I don't have to try and prove what I'm thinking because we can already see what it is. All right, so another set of intersections here. We can see A and B. So C is going to be an odd whole number. So I might put C over here, an odd whole number, 1, 3, 5, 7, 9. Okay, I'm going to kind of cap it off there because I see all the other ones stop at 8. So we're kind of done with those. All right, so I want the intersection of A and B. So what's in A that's also in B? 2. Do I have a 4? No. Do I have a 6? Nope. Do I have an 8? Yes. Okay, so I get 2 and 8. That's my intersection. What about A and C? Okay, so A and C this time. Do I have a 2? No. Do I have a 4? No. Do I have a 6? Nope. Do I have an 8? Nope. Okay, so this is another disjoint set. Okay, sometimes we call that a no solution because they don't share anything. All right, what else do we got? We got C and B. Okay, so that's these two things here. So do I have a 0? Nope. Do I have a 2? Nope. Do I have a 5? Hey, yeah, we got a 5. What about a 7? Yep, got a 7. What about an 8? Nope. 9? Nope. Okay. So my intersection, things shared between C and B, that's 5 and 7. All right, we can have more than one at a time. Okay, so we might say first 5 letters of the English alphabet. A, B, C, D, E, 1, 2, 3, 4, 5. Okay. B is a vowel. A, E, I, O, U. And vegetables all written out for us. Okay, so if I want a union, okay, so these aren't ones that are shared. That means I need all of them. Okay, so the first thing I might do is just go ahead and list all of A, B, C, D, E, okay, because A is taken care of, E is taken care of, so I'll add on I, O, and U, and then we'll add to that. What else did I not have in vegetable? V, E was taken care of, G we need, E was taken care of, T, A was there, B was there, L, and we already had E multiple times. Okay, so we talk about a union, right? That means we want to include everything that there is, right? Just like George's main idea of unions. So what we're going to do is end up with a pretty long list. Intersections, usually they're going to get smaller unless they were very, very large sets to start with. So what's shared between all of these? So I just go through each one. So I have A, and A. Is B? No, I don't have a B. It has to be in all 3 of them. So as soon as it's not in one of them, so AE, so I might jump the whole way to E because that is in all 3 of them. And that's everything between A and B. So I really don't need to check for anything else because as it says here, it has to be in all 3 of them, right? So remember intersection, those are things that are shared. Unions, that means we unite all of the sets that we have. All right, so how are we going to use this? We're going to use this idea in a couple ways. So we're going to use some Venn diagrams. We have 500 commuters are polled, right? Those are some people, they go, they work someplace other than at home. They take either they drive or they take public transportation, but some of them do both, right? Sometimes they drive, sometimes take transportation, or they may drive to public transportation. All right, 200 commuters drive to work and 125 use both types. How many commuters take public transportation? All right, so we have some overlapping ideas right now. So let's get a Venn diagram put on here first, and let me label some things that we have. So some of them drive, some of them take public transportation. All right, so what do we know? So this whole thing has to be 500. And out of the ones that drive, so that means this circle right here has to have 200 people in it, right? So that's information that we were given. It all has to be a grand total of 500. The number you drive and use public transportation. So that means this number here goes right in the middle, 125. All right, so we'll do some basic math. So if this entire circle for drive has to be 125 minus the 200, because the whole thing's 200, but I take away 125, that means this is 75. All right, now the other part is that this circle over here, if that circle is 200, this one has to be 300 because the grand total is 500. So I need 300 minus 125, that's 175. So I have 175 people that only use public transportation. So we have to do some logical thought process to get through these. All right, let's try that again. All right, 30 students in student government, 20 are honor students, and 9 are officers and honor students. All right, so it looks like we have student government and honors. All right, what do we have going on? Something that we know. 9 are both, right? So 9 go here, but there are 30 students in student government. So that means this whole thing has to be 30. So how many are left over? 21, because now this entire circle makes that up. And 20 have to be honor students. So this whole circle has to be 20, but we already counted 9 of them. So that means we need 11 over here. All right, so it's not too bad once we see how to work those things together. So we're looking for something that's both, and that goes in the middle of that Venn diagram. All right, so what's this have to do with what we have been solving? So we're going to continue solving absolute value. So I need 2x minus 1 is less than 3. Don't forget, we also need 2x minus 1 is greater than negative 3. So we're going to add 1 all over the place here. So 2x is less than 4. We're going to divide by 2 to get all of our steps out here. X is less than 2 and x is greater than negative 1. Let's take a look at it. So 0, 1, 2, negative 1. We got open circles. We want to be less than 2 and we want to be greater than negative 1. All right, so here's what we want is this whole thing, since it's the area in between, right? This is like the two roads cross. So this must be the intersection of the two. So we're going to use that N for intersection, right? And it goes along with the idea that this would have been an and because we get both parts. Okay, so if I have to label it as a intersection or a union, we get our intersection. All right, now number 1, or in letter A, number 1, we deal with this and we know by the way it's written, it's supposed to be an and, so we're hoping to have an intersection in the end. So let's take a look at what happens. So minus 5 on all 3 sides. So 3 is less than x. And I'm going to go ahead and separate this one. Normally we leave it all together. X is less than 6. All right, so x is less than 6. So let's put 6 out here. Open. And x has to be greater than 3. Greater than or equal to. So we'll fill this one in. Okay, so again, we assumed that would be, and now when I graph it, it confirms that it is an and that and becomes an intersection of the two. All right, absolute value this time. So we need 2 inequalities here. The first one's identical. And we use 4x minus 6 is less than negative 14. You guys know I love to write both of them out. That way we solve. We're going to get different numbers, but the problem itself gets solved exactly the same way, right? Add 6 everywhere. Add an equals to, I don't see it there. Okay, negative 8. Divide by 4. X is greater than 5. X is less than negative 2. And when I throw this on the number line, 0, 5, open, greater than 5. Here's my negative 2. We're going to be less than negative 2. And we get that or situation. Okay, but I need both parts of this to count. So what happens is your or is now a union. All right. because what are the solutions? Well, it's everything greater than 5 and it's everything less than -2. So we put those two things together to get that idea. All right, so we'll do some of this stuff as we review in class, and I'll see you then.